In the previous lesson, we learned how to multiply radicals, so the next logical thing would be to learn how to divide radicals. But before we do that, let's just review some things we did a long time ago. Multiply things like this. Hopefully you remember that looks like the factoring of the difference of two squares. And you're right, because when I FOIL this out and get x squared minus 5x plus 5x and a negative 25, what happens is those middle terms add to 0 and you get the difference of two squares. This is going to become very important when we start dividing here in just 1 minute. So let's look at this with square roots. The square root of x times the square root of x is just x. Remember, when we square a square root, they cancel each other out. And then we're going to have negative 5 square root of x and a positive 5 square root of x and then that negative 25. So just like up here, when those middle terms added to 0, we have the same thing. Also notice what happened is that we started out with a square root and we don't have a square root anymore. Let's look at this one last thing. Hopefully you're going to see the pattern. If you have a positive and a negative, those middle terms are going to cancel out. The square root of 3 times the square root of 3 is just 3. Then we have negative square root of 15, positive square root of 15. But look here, it's going to be negative. Square root of 5 times the square root of 5 is just 5. So those are going to add to 0. We can put those together and just get negative 2. So not only did the middle terms add to 0, another thing that happened is that the square roots all went away. And that's what we're going to need when we're dividing those radicals. So what we've just looked at is what's called the conjugate. The conjugate of the square root of x minus 5 is the square root of x plus 5. The middle signs have changed. The conjugate of this is the conjugate of this one is that, and again it's the same binomial, but the middle sign is different. And when you multiply those together, it's just the difference of two squares. And so when we do this, we can square each term and then subtract. So if I had the square root of 2 minus the square root of 7 times the square root of 2 plus the square root of 7, I could FOIL it out like I did up here, or I could square that and get 2, square that and get negative 7, and that's why I subtract because of the minus and the positive, and get a negative 5, because as we've seen, those middle terms add to 0. So we're going to use that conjugate to rationalize the denominators. Now recall, we've rationalized monomials, now we're going to rationalize binomials. Alright, let's look at this first example. The directions are to rationalize the denominator, that is dividing radicals. As you recall, rationalizing the denominator means to get rid of the radicals in the denominator. That's what rationalize means. How are we going to do that? We're going to multiply by the conjugate. So the conjugate of this binomial is the same binomial, but with the middle sign changed. Whatever we do to the bottom, we have to do to the top. Right? So this is just like we did before. We multiply that out. The square root of 5 times the square root of 5 is 5. Multiply those is 1, and we subtract because I have a negative and a positive. So we square the first term and we square the last term and we subtract. Now you can multiply it all out like we did before and FOIL it, but hopefully you will see those middle terms are always going to add to 0. So this is just a little bit faster. Then we're going to distribute on top. Okay, let's clean that up. So 5 minus 1 is 4, and on top those are unlike terms, so we're just going to leave those answers. Okay, so one more time, rationalize the denominator means to get rid of the radicals. And if we have a binomial, we've got to multiply by the conjugate. Let's just do a couple of more examples. Ooh, we have lots of square roots. And the idea is we want to get rid of those square roots in the denominator. So we have the same binomial, but we change the middle sign. Let's do the bottom. The square root of 6 times the square root of 6 is just 6. The square root of 2 times the square root of 2 is just 2, and we would subtract. Or you might want to think about it, that's the square root of 36 minus the square root of 4. And of course, that's still 6 minus 2. Right. Then I'm going to distribute. So I have the square root of 18 minus the square root of 6. Let's do the arithmetic. So that's 4. But the square root of 18 can be simplified. Remember, that's 3 times 3 times 2. So I can take out a 3 and leave a 2. 6 is just 2 times 3, so there's no pairs, so I would just leave that. There's my answer. We cannot reduce, even though 2, 6, and 4 are all even, you can't reduce them because these are in the radical, that's outside of the radical. So that's all we can do. My goodness, now we have 4 square roots. That's okay. We could do this a couple of different ways. We could simplify the square root of 8 first and then multiply by the conjugate, or we can multiply by the conjugate and then simplify. I think what I'm going to do is I'm going to go ahead and just multiply by the conjugate. Right? So what is that conjugate? It's the same binomial, but we change the middle sign. Right? So the square root of 6 times the square root of 6 is 6. That's 8, and we have a minus sign. Ooh, now on top, what are we going to have to do here? We're going to have to FOIL that out, all right, because we have a binomial times a binomial. Let's just do it a step at a time. So that's going to be the square root of 48. Now that, remember, is just 8. Square root of 8 times the square root of 8 is just 8. Then we have minus the square root of 12 and minus the square root of 16. Okay, I think we have a lot of cleaning up to do. 6 minus 8 is negative 2. But what about that square root of 48? Let's see, 48 is 6 times 8. That's 3 times 2. Or that's 3 2's. Let's see. I could take out 2 2's. So that is a 4 times the square root of 3. And we'll take out a 2, another 2. We would multiply that together, and the 3 would stay underneath the square root. Plus the 8. 12. Let's see, 12 is 4 times 3. So the square root of 4 is 2. So I'm going to take out a 2 and leave a 3. Don't leave out that minus sign. And then we all know that the square root of 16 is 4. Still not done because I need to collect like terms. Those are alike because the square roots are the same. And of course those are alike because they're just regular numbers. Right, so I keep the denominator. So I'm going to put those together. 4 square root of 3 minus 2 square root of 3 is just 2 square roots of 3. And then 8 minus 4 is a positive 4. Are we done? Not yet. All right, how can we possibly reduce that fraction? Very carefully. I want you to circle all the numbers that are not in a radical. All the numbers that are not in the radical. And ask yourself, are all 3 of these divisible by something? Yes, they're all divisible by 2. So we can reduce. 2 goes into 2 one time, 2 goes into 4 2 times, 2 goes into negative 2 one time. So we have 1 square root of 3 plus 2 over negative 1. Want to be very careful when you reduce. Again, circle all the numbers that are outside the radical. If they all can be reduced, then you reduce. Now let's do our last example, but with letters. We haven't done one of those. Same idea. You want to multiply by the conjugate to get rid of those square roots in the denominator. So same binomial, but change that sign. Square root of 3x times the square root of 3x is just 3x. Then we need that minus sign, and that's just 5y. Hopefully you're getting the little tricks. Makes it a little bit faster. Now unfortunately up top we're going to have to do that foiling, and it's going to be pretty messy. That times that is the square root of 6x squared. Then we have minus the square root of 10xy minus the square root of 3xy, almost out of space. A negative times a negative is a positive square root of 5y squared. Okay, can we simplify? Well, I do see these perfect squares, so they can come outside of the radical. So I have x times the square root of 6. And then these are not alike because there's a 10 and a 3, so I'm just going to keep that as is. And then here the y can come out, but the 5 stays in. All divided by 3x minus 5y. We're also unlike. Nothing that can be reduced, because if we circle everything outside the radical, there's a 1 and a 1 there. Those are not all divisible by the same thing. So this is our final, very ugly answer. So here's the key thing you want to remember is you want to use the conjugate to rationalize the denominator. And remember, when you multiply conjugates, you square each term and just subtract, because that middle term cancels out.